Hi, in this video, we're just going to make a brief connection between what we've done so far in terms of finding zeros, and in particular, looking at the completing the square, and how that translates to kind of where we're headed in the next unit, which is being able to graph quadratic functions and other functions as well. So just a reminder, this is turning point form, a outside of x minus h all squared plus k, but instead of setting it equal to 0 like an equation, quadratic equation, I set it equal to y, and therefore it becomes a function where we're mapping values of x against a calculation which gives us a value of y. So I wanted to sort of show you why it's useful to have it in this thing called turning point form. If I have a quick look at Desmos here, I've got the basic quadratic function graph, which is a shape called a parabola, like so. It goes down, hits 0, and then goes up again. It's symmetrical because as I square a negative number, I get a positive number. And of course, if I square the same number but it's positive, I'll get the same output as well. So it's symmetrical. So we've got y equals x squared here, but look at what happens when I add or subtract a value to x, like x minus 2. Then you can see that this bit down here where it stops going negative and starts going positive has shifted from 0 to 2. So that point there is called the turning point of the function, because it's going from one direction to another. We'll explore it in more depth in the next unit. So that's x minus 2, and if I go x plus 2, guess what? It goes 2 units in the other direction. Somewhat counterintuitively, you've got a plus 2 here, but it goes backwards 2 units. If you think about solving for x with x plus 2, figure out what x is equal to then. Okay, well, that's that one. But what about if we add something onto the whole of that squared term, like 1? When I do so, it stops being at minus 2 and goes, it stays at minus 2 in a horizontal direction, but it's gone up 1 unit. And I'm sure you could imagine it would be a similar story if I go down 1 unit. Down it goes by 1 unit here. So that means the turning point effectively has gone back 2 units and down 1. So the turning point can be directly read from the equation by just considering the values here and reversing it. So x plus 2 becomes negative 2 and negative 1 stays as it is. And so the turning point of this function ends up being negative 2 minus 1, which I can write as a point here so you can sort of see it. Negative 2 minus 1, it's that blue dot, and that's the turning point. And that's why it's called turning point form. By the way, if you're wondering what the value of a does, so if I put 3 here, for example, have a look at the graph, have a look at the turning point, have a look at the graph. I put 3 in, and the turning point didn't change, but it got thinner, didn't it? 5 got even thinner still. If I go for negative 2, then you can see that it flips the graph. And if I go for a fraction like 0.5, it becomes fatter. There you go. So that's what the nature of A is, but it has no impact on the turning point. It does have an impact on the zeros. What? You don't know what zeros are? Well, the zeros are these 2 points here. And a 0 is where the line cuts through the x-axis. And I guess it's called a 0 because it's where the equation or the function y is equal to 0. So it's the solutions for x, or the values of x, such that y is equal to 0. So these are 3 critical points of a quadratic: the zeros, the turning point, and the fourth one being the y-intercept. Okay, that's a little bit of background here. I'm going to go through just one simple example, and that'll do us for today. So again, just to highlight those critical points, we've got zeros here, sometimes called the x-intercepts, and can be solved by setting y equal to 0, and therefore we're setting a outside of x minus h all squared plus k equal to 0 and solving. And you've done that before. This, I've deliberately just gone off center a little bit, is called the turning point, and the turning point is h comma k. And you might get a sense now as why it's always written as x minus h, so that we've just got a positive h here in our description of it, regardless of whether it is actually positive or negative. Okay, so I'm just going to go through one example and then we'll leave it there for this time. So we've got y equals x squared minus 4x plus 2. So we're going to put it straight into, this is not too hard, this one, so we're going to put it straight into completing the square form. So x minus 4 divided by 2 is x minus 2 all square. And then I'm subtracting that value straight away, minus 2 squared plus 2. And that's equal to x minus 2 all squared. Minus 2 squared is minus 4 plus 2 is minus 2. We now have it in turning point form, where a equals 1. You don't have to do this bit, I'm just doing it for the sake of it. H equals 2, because remember it's x minus h, and k is equal to negative 2. So the question will ask something like state the zeros and the turning point. So straight away, you can just use TP for turning point. Turning point is equal to 2 comma negative 2. Turning point form tells us that. The second thing it will ask you to do, and I'm just going to zoom out and go to slide 18 for this bit, is it'll ask you to work out the zeros. So to work out the zeros or the x-intercepts, we simply set the turning point form equal to 0 and we solve. So I'm going to add 2 to both sides to get x minus 2 all squared is equal to 2. I'm just doing this quickly, I hope that's okay. I'm going to, not square root 2, but I'm going to square root both sides. And that gets me x minus 2 is equal to the square root of 2. But because variables are involved, we make it plus or minus. And I'm going to add 2 to both sides. So I've got 2 plus or minus root 2 as my answer, which is 2 plus root 2, or, 2 minus root 2. They're the two zeros. If you want to be a little bit more precise, and there's nothing wrong with that as well, you could write them as coordinates, and that would be entirely appropriate to do. 2 plus root 2 comma 0, 2 minus root 2 comma 0. Now, just a little heads up, and then I'll finish the video and say, if this was a functions unit and you were sketching it, this is where you would plug this value into your calculator to get an approximate decimal value so that you know roughly where to put the 0 on your sketch, and similar with 2 minus root 2. So just keep that in mind, that for an exact answer, what I've written is perfect, but for in practical purposes, we'd probably use our calculator to work out the actual values. Okay, I'll leave this video here, and you have a crack at doing some from the textbook.